let's look at some similar triangles. Similar triangles have the same shape, but they're not always the same size. If you know your triangles are similar, then the angles are going to be equal, but the sides may not be the same length. Corresponding angles, that's the ones that are in the same spot, and we'll talk more about that in a minute, will have the same measure, and corresponding sides will be proportional. So let's look at this one. For this triangle, see how they're similar? The angles are going to be equal, and the sides are going to be proportional. So angle A is going to equal angle D. Angle C is going to equal angle F. Angle B is going to equal angle E. And these sides, AC is going to be proportional to DF. CB is proportional to FE, and AB is proportional to DE. And what's interesting, you can tell by proportional, I mean they're going to be divisible by the same number. So 6 divided by 2 is 3. 8 divided by 2 is 4. 4 divided by 2 is 2. These are proportional, and we'll figure out how to solve those. So we are going to use these rules to find the missing length. So they have the X over here. So this is what we're looking for, okay? Now, these are similar triangles. So what I want you to imagine is putting them in the same spot, okay? They tell you that this angle equals that one. If I were to take this triangle and rotate it around so that they matched, I would have this triangle, okay? So I just took this triangle and I flipped it a little bit. We want it to look like the other one to make this an easier problem. Let me do that again since I messed that up. Okay. Now, if I flip this over here, okay, the X, okay, if this angle's going all the way over here, the X is going to be in the same spot as the 7, right? If I flip it over here, this 8 is going to end up in the same spot as the 5. And that's what it would look like, okay? So I can set up a proportion. Let's look at this triangle and this one, okay? I can say 5 is to 8, right side to right side. So 5 over 8 equals 7 over x, left side to left side. When we know they're similar, we can set up proportions, okay? And we can solve. All right, so on this one, well, how you solve it is you cross multiply. 5, oh, that was terrible. I wrote on top of it. Let's try that again. 5 times x is 5x equals 7 times 8 is 56. And when you divide by 5 to get x by itself, you find that that angle is 11.2 inches long. So that would be, or excuse me, not that angle, that side. That would be this side, 11.2. Let's look at another one. A man who is 6 feet tall is standing 10 feet from the base of a lamppost. The man's shadow has a length of 4 feet. How tall is the lamppost? Okay, so here's our lamppost. We don't know what it is. We're going to call it X. Here's our guy. He'll be 6 feet tall, and his shadow is 4 feet tall. You also had a hint of he's standing 10 feet from the lamppost. Okay? Now, before we set this up, sometimes it's easier for students if we pull this out. So let me pull that out, and let's rewrite that over here. So the man was 6 feet tall, and his shadow was 4 feet. Now we know that this will add up and give me 14 for this one. Okay, so now we can set up a proportion. Left side, left side. So x over 6 equals bottom over bottom, 14 over 4. Okay? And you could go x over 14 equals 6 over 4. It doesn't matter. You can do it either way. We're going to cross multiply here. So we're going to end up with 4 times x equals 6 times 14 is going to give us 84. Then we're going to divide by 4. And we find out that x is equal to 21. So the height of that lamp post for these to be similar triangles would be 21.